Hi, my name is Vesa Juvonen and I work as a principal consultant in Microsoft Corporation. In this module we'll cover the new client object model and REST API functionalities. These are both new technologies or capabilities available within SharePoint 2010. We'll begin this presentation with introduction to the client object model. We'll discuss how it fits to the overall developer landscape, and we'll also explore the different potential usage for it. Next, we'll cover the 3 different client object model implementations, and as a final topic, we'll discuss using REST to access list information, which will include a discussion on how we can leverage it using WCF data services. So let's start by going through the introduction to client object model. We'll cover goals of the client object model and how it has been designed and implemented. As a refresher and to set the context, when we wanted to access information remotely in SharePoint 2007 implementation, we would typically use web service interfaces. Writing code against web services was not a difficult task. However, it was not that flexible either, and our potential solutions were limited to what the web services could provide. Additionally, there was ways we could utilize WCF with SharePoint 2007, but this required making additional configurations and changes, such as registering the required .NET Framework components and writing a custom virtual path provider to enable access to SVC files. So the overall challenge in SharePoint 2007 was that using the web services to create custom flexible solutions often resulted in a greater level of complexity at the code level, as developers attempted to create solutions which could not be completely satisfied using the available web services. In addition to this, the web services were also difficult to call from JavaScript, which meant that implementing complex functionalities using the client technologies was difficult. It was common for developers to create custom wrapper services as well, in an attempt to make using and consuming the web services easier and more flexible. This typically resulted in increasing the overall customization costs for these kind of projects. To this point, similar wrappers and functionalities were developed over and over again by different customers within their project. Microsoft noted this and determined that this was an area of project and developer experience which needed to be improved in 2010 release. So moving to SharePoint 2010. The goal of the client object model is to provide simple and easy API which can be used to add, retrieve, update and manage information and content stored in SharePoint. To this end, we've actually made 3 different client object models available, and developers can choose between using the .NET client object model, the Silverlight client object model and the JavaScript client object model, depending on their project and solution objectives. The primary objective of the client object model is to provide consistent and efficient API to manipulate SharePoint objects remotely. There are few steps involved when accessing SharePoint using client object model. In this diagram, the client application refers to the client-side application which consumes the client object model. Client object model encapsulates the calls over the network. As a developer, we don't have to be aware of the technical details, since client object model takes care of the plumbing for us. All calls executed are sent over the server side using XML. On the server side, a client SVC WCF service handles the call and executes the requested server-side APIs to perform the requested actions. The client SVC also returns the values back to the caller, which are then converted to strongly typed objects. This model provides consistent and easy access to the information, and depending on the client object model you use, the model is almost identical. As we can see from the table on the slide, the client object model provides similarly named objects to access the information and content stored in SharePoint. The primary difference you'll notice is that the naming convention is different. In the client object model, the client object model doesn't use the SP prefix. You'll also note that the object naming is consistent for all of the client object model types, which makes it easy to work with each type. The client context object is central to all operation, and it provides the primary actions used for obtaining and working with the different objects. Additionally, the object member names are mostly the same as those of the corresponding server-side objects, with the primary difference of being those used in JavaScript client object model, which have a little bit different way to access the, for example, properties. This slide is useful in defining the main objects available in the client object model. As you can see, the client object model is useful not only for list information, but it also supports many other SharePoint objects as well. As you can see, we can use the client object model to manage site collections and site information such as lists, item, files, web parts, and you can even make use of it when you work with the user permissions. There's also support for manipulating and modifying navigation. All of this functionality is a subset of the server-side object model, which is focused on working with objects located in a single site collection. So let's take a look at some of the things which we need to do to get started with implementing a client object model within our code. Once we have set up the references, we need to create the client context object. We use the client context object to define the actual site collection which we will be accessing via object model. We'll need to create this object before we are able to request or access any information on the site. As you can see from the slide, we'll need to use the load method of the client object model, and then we'll need to make sure that all requests to load the information are committed in a batch. Essentially, this means that we can batch multiple calls before actually executing. Actual execution of these calls is done by using the execute query method available on the client context object. As mentioned in a previous slide, we can batch the calls before executing them. So this means that, as illustrated on this slide, we can make it so that multiple requests are executed at one time when we call the execute query method. These requests are sent to server via XML, and the client SVC is responsible of executing the commands in the same order as they were requested on the client side, which follows the first in, first out model. After the requests have been executed, the client SVC will provide any requested information back to client side. By batching the commands, we are able to increase the performance of the client object model, and in this way, the overall network consumption is optimized based on actually used information. The model can be a little bit confusing at first, particularly if you've been developing using server-side object models in past. However, it's relatively straightforward and very easy to use when you get used to it. Now that we've gone through the overall of the model, it's important to note that there are a few limitations of the client object model which we want to be aware of. First, you'll notice that we still need to handle the sync update semantics for possible changes. This means that you'll need to handle the cases where you have loaded the information in the client object model and somebody has since changed this information on the server. For instance, if you loaded list information into a client OM and then the data was changed by a user on the server, you might see conflicts when you try to apply your client object model updates back to the server. Another thing to point out is that there's no way to elevate privileges in the client object model. Finally, the .NET CLR client object model is asynchronous by default. That said, you can still use the standard .NET capabilities to make the call asynchronously. In addition to this, the Silverlight CLR and JavaScript object model are asynchronous, which makes sense due to the nature and implementation scenarios for these technologies. Now that we've completed the overview of client object model, we're gonna move into a deeper dive into the .NET client object model, which you can use to provide remote access to SharePoint information, for example, from console or Windows Forms applications. The .NET CLR client object model provides easy access from .NET clients to SharePoint information. It can be utilized from a managed code, including Office clients. You can, for example, provide custom action pane in Word to get some information to your Word document from server. Assemblies to provide the client object model connectivity are located in the ISAPI folder under 14 root. By default, this is C, program files, common files, Microsoft Shared, Web Server Extensions, 14, and ISAPI folder. There's two different assemblies available, which are Microsoft.SharePoint.client.dll and Microsoft.SharePoint.client.runtime DLL. Size of the assemblies are considerably smaller than the default SharePoint assembly Microsoft.SharePoint.dll. You can distribute these assemblies as part of your client-side application to enable easy deployment and installation of your applications. This is relatively simple example to show the .NET Client Object Model code. As we covered in previous slides, we first need to establish the client context. We use the client context object to define which site collection we'll be using. The following step is to define the operations to be executed. We define these using either load or load query methods. Load method will fill out objects within the context. In the example, we use this method to fill out the web and web lists objects. Notice that the order does matter, meaning that since we are accessing the lists within the lists collection, we'll first need to request the web object. The load query method lets a developer to use LINQ query to get custom objects back from SharePoint. Notice that these query objects are not loaded in the context, meaning that if you query lists in web using load query method, the lists property of the web is still 0 unless we've loaded the lists earlier. It's important to know when considering the link-based query syntax that there's two different concepts to be considered. We have the so-called LINQ pretty query syntax, which is kind of a LINQ everybody knows and loves and uses the SQL-like type-safe clauses. The other option is LINQ lambda syntax. This is a less friendly, but at least a consistent and a more powerful way to request data using LINQ. Although a lot of scenarios may start with a pretty query syntax, in many cases lambda syntax must be used for more advanced scenarios. Good example of the power of client object model is, for example, the file handling capabilities. In 2007 version, submitting files to SharePoint from a remote location was surprisingly difficult. In 2010, with the client object model, we can accomplish this extremely easily. As you can see from the example, we only need to create the client context, and after that there's support for uploading file information to server. In this case, we are deploying our locally present client-owned upload docx to shared documents folder located in a remote SharePoint installation. Let's have a simple examples of utilizing the client object model in our .NET application. We'll access the information from SharePoint remotely and also use the remote file handling capabilities to automate file upload from client side. We'll also have a look on how the client object model could be utilized from Word client.
In this demo, we'll concentrate on a .NET client object model and how we can actually manipulate and access the information in the SharePoint remotely. So the demo consists from 3 different things which we will demo concerning the intranet site which we are using here. So let's move actually and to console application first, and what we have done here is a simple console application to where we have actually associated 2 assemblies which will provide the client object model functionality for .NET clients or .NET code, as in console applications, forms applications, and so on. And when these 2 assemblies have been referenced, we have the Microsoft.SharePoint.client namespace available to access the information in SharePoint site remotely. Let's go through and start walking through the actual code of this relatively simple example, so you kind of understand the process of handling the calls and actually executing the execution actions over the network. Since, as we covered in the slides, client object model optimizes the network traffic not by getting all the information at once. We are only getting that information which is actually relevant, so basically meaning that we are requesting that information explicitly to be used. So within the code, we first initialize the client context, which basically means that we are telling to which site we are accessing and which site collection we are accessing, and after that within the code we first try to access or get instance to the site object, which would mean the SP site in a server-side code. So basically we're trying to access and request the site collection URL from this particular object. But that doesn't actually work. The reason for this is the fact that we are unable to, well, we haven't requested the information concerning the site collection yet. We have only set up the initial plumbings or initial settings of the objects, but we haven't explicitly tell the client object model that we are interested of the site collection information. Let's move forward within our code and basically let's solve the functionality. So how do we actually request the information? The site collection in here is site object. So we have created that object instance, but we need to explicitly ask the client object model to fill it up for us. So we're using the load method of the client context to store information of which objects we are interested, and then the execute query is the time when we actually access the SharePoint installation remotely. So when we do the execute query, there will be WCF calls happening on the background, which are accessing the client CVS service, which is located in the SharePoint side, and that service is responsible of executing the actual commands. In this case, we have requested information concerning the SP site or site object in client object model. So basically meaning that that object will be filled up and the properties are actually available. So we're actually capable of reading the URL of the particular site object. So the same thing applies also for other objects. So in this case we try to access the web object of the client context. If we try to do if we haven't loaded the object information from the server side and we are trying to access the properties, we get the same exception since we haven't requested that information to be available and we haven't executed the actual query yet. Basically meaning that let's use the load method again to load the particular site or web object, or tell the client object model that we're interested on that particular object information, and then the actual execute query will execute or get the information from the server side. And at this stage we can actually see, or we have requested information concerning the title or the other properties of that particular object as well. So if we have a look on the object properties, we can see that all the base properties are filled up and they are available to be used. If we want to access these sub-objects, for example the lists and so on, we need to again request that information to be available and then call the execute query as well. And that kind of optimizes the network level traffic, which we are doing from the remote location to the server side. So if we are, for example, interested on the lists of the site, we are able to do that by saying that we want to load the lists, and then we do the actual execute query so that we get the list information to be available. The other example here is that we are creating a Ling query concerning the lists which we are actually interested. So we are creating this filter and then executing that query over the server, over the remote connection. So the list information would be actually available. And as a final step, relatively simple, we're listing all of the lists within the particular site. And the key point here is the fact that we are even unable to do development of the client object model remotely. So if you are only accessing the information within the SharePoint using the client object model, you don't necessarily need to have the server-side object model installed on your same environment. And as we can see, now we have now requested the list information from the server side. Key point here is to remember that we need to request what kind of information we are interested. So first we create the client context, then we are telling the SharePoint client object model which kind of information we are interested of, and then we do the execute query to get that information in. Let's move to another example. So this was remotely accessed from the console application. Let's do something else. This is an example console application again, but it's a little bit more interesting in that sense that it enables us a way to upload files directly to, in this case, to the intranet.contoso.com address. And how do we actually do this? We need to create the client context, and the client context basically, after the client context has been done, in this case we are actually looping through different files which we are interested of, or we want to send over the remote location from our client side. And then we are opening up the file stream, and within the single line of code we are basically putting the file stream to the server side. And the client object model is taking care of the whole transmitting of the information to the server side. The example which actually we have here is a relatively interesting one if we think through different capabilities of the client object model and how we can actually utilize it. In this case, the SP is sent to is a simple exe, a simple executable which is executed on the remote on the client side. And the idea is that we actually compile this application, and after that we run this really simple registry entry, which will actually tell the particular Windows client that they will have underneath the right-clicking of the mouse, we will have a copy to intranet selection available. And if that is selected, we are actually sending or executing the send to exe, which is also present in the C root, and we are bypassing the folder location, which we actually right-clicked on. So, meaning the fact that we are actually getting the folder location to our console application, and based on the folder location, we can then connect remotely to the intranet. and submit our files to shared documents folder. Let's have an example or try how it actually works. So we do have executed the registry properly already, and if we go to the desktop, I have here one document which actually has folder which actually has 4 documents in it. And what the registry entry is doing, it's adding a capability to right-click any. When we right-click any folder, there's a new function available or menu available, which is a copy to intranet, and that will start executing our exe based on the settings which we added to the registry. Basically meaning again the following. Let's have a look on the intranet front page. We can see that the shared documents is empty. There's no documents currently available. And if we go back to my remote computer and we right click the docs folder and choose copy to intranet, our execution starts and we start uploading the files and we're gone. And what happened during the execution was the fact that if we now go to the intranet and refresh the page, we can see that those 4 documents were uploaded properly to the intranet shared documents folder. Really nice functionality at the moment, a really nice functionality, and it demonstrates really well the capabilities of the SharePoint client object model. Currently, all of these URLs and everything else is hard-coded, but obviously you could, for example, say have the same functionality to send documents or any files from any folder to person's own personal site, as in my sites. Or you might have a content organizer enabled in your intranet, which will actually further analyze the documents and send them to proper locations. Really simple functionality, but really powerful when you start thinking different options which are available. As a final example, let's move on. Let's have a look on how can we utilize the client object model also in Word clients. This example relies on a simple list which exists in our intranet. So within the employees Word, there's an employees Word list within the intranet root site, which has the 3 items in it. We have Vesa, Juvonen, James Petrosky, and Todd Carter listed here. And the functionality is relatively simple, but what we've done is that we've created a Word application from the Visual Studio, which basically means following. So if we would be adding a new project, we're able to create these Office projects, and in Office projects we have the Word application option available. And let's choose 2010, and that's totally. And from here we can start creating these Office client add-ins and applications which are then available. In this case we've created Word 2010 document template. And for that particular Word document application, we've added some small code, which is in here. So we're basically creating a new instance, or whenever the document actually starts, we create a new element host, and for the new element host child property or the controls hierarchy, we are adding the custom navigation, one custom action pane. And for the custom action pane and for the actual element host, we are putting that to the documents actions pane controls, which would basically mean that we are showing our custom action pane, which is available here, within the custom actions within the Word application. This custom action pane is relatively simple, but the code behind of this particular fellow does something interesting. So what it actually does, it accesses again the intranet using the client object model. So we are creating the context object first. Then we are interested on the list object or the lists. So we're telling that we are interested on that. And then we have the COM query, and we want to get the information from that particular list. So we get the list item collection, list of employees, and after that, or we're setting the initial values, and like within the any client object model, execution or coding, we are first telling what are we interested, then we actually do the execution of the query. And then what we actually do the next, we are setting the item source for the list box within that custom action pane to be the employees list. And after this, we can actually then change the application values, the templates or controls within the Word application, within the Word document, based on the selection which we have in the list box 1. And the list box 1 was in the action pane. So how does it actually look? And let's actually have a breakpoint available in here, so you're able to see what actually happens. We'll start the application within the Visual Studio, and the Word 2010 starts, and within our template we now have these custom functionalities available. We have the custom action pane, which will now access the list which we actually have in the user within the intranet, and shows these 3 people to be available. And from those 3 people we are actually getting more information. We're getting title and additional information as well. So whenever we select one of the items, we are accessing the information and filling up the employee name, title field and a city field. Which basically means that we are updating the document information based on the selection and items which we actually have within the intranet. So we can really easily create the document, save this document, and since these are marked elements, quick parts within the Word documents, they are named elements, we're able to access those from our custom code as well. So if we now close up the Word document and we need to update, let's say this is customer information, and the customer information is actually updated in our intranet. Let's add here architect and Kimmo Force, and city is Helsinki as well. So let's add Kimmo here, and let's start the Word application or the template one more time. Meaning that somebody creates a new document again concerning the same template, which will mean that the new option is now available, and when we select Kimmo or whoever, we are updating the information based on the list information which we have in the SharePoint. Accessing maybe HR systems or CRM systems may be a little bit more difficult, but you can definitely, for example, have an external list as your primary source, or have integration point within the SharePoint. So having the SharePoint as your integration point to CRM data as well, and then you can generate these documents on fly based on the selected item. Just to give you an idea what could be theoretically done. That sums up the demo. There was 3 different demos for concerning the .NET Framework client object model. And for all of these, obviously, we always need to start by adding the client, Microsoft SharePoint client and client runtime DLLs references. And these are located in the default ISAPI folder underneath the 14 Hive. I think that sums up our demo quite well.
In this section, we'll concentrate on utilizing client object model in Silverlight. We'll also generally cover the steps to develop Silverlight applications in SharePoint environment, which is well supported within the Visual Studio SharePoint project templates. Silverlight itself is natively supported in SharePoint 2010. In 2007, you had to perform a few additional configurations in server-side to enable Silverlight. You can use Silverlight in a separate ASPX page or in a web part. There's out-of-the-box Silverlight web part available, which supports to assign initialization parameters for the Silverlight applications. The same model is definitely available if you write your own custom web part to host Silverlight applications, but you'll need to write the required code to assign the initialization parameters for the Silverlight applications by yourself. The sub file containing the actual Silverlight application can be deployed to layouts folder in 14 root or content database and loaded at runtime. Deployment to content database means that you can deploy your application just by uploading subfile to a document library. Obviously, you can do the same also by using feature framework. Silverlight application can then make use of the client object model to access and manipulate objects within the SharePoint. So what are the options for Silverlight integration what are the options for Silverlight to integrate with SharePoint information? We can use either web services, which provide most coverage on the functionalities to use. We can also use the client object model, which is extremely straightforward way to access SharePoint information. If you only need to access list information, you can use REST interface, which is the easiest option to connect to SharePoint information. We'll cover the REST API more detail later on this presentation. For Silverlight client installations, Microsoft SharePoint Foundation deploys Microsoft.SharePoint.client.silverlight assembly and Microsoft.SharePoint.silverlight.runtime assembly into a special script-only folder located underneath the _layouts folder. This folder is named as client bin, which is a common naming conventions for folders which host the actual XAP files. This folder is designed to be the standard place for hosting assemblies that are used in Silverlight. There's a client object model redistributable planned, which would be the official channel for developers to get these DLLs. Also, there is a XAP file that can be dynamically included in customer Silverlight application, which will ease supportability and size changes. This is an example of utilizing Silverlight client object model for creating lists and list items. In a similar way as for .NET client object model, we'll first need to create the context object. In this case, we can get the current instance by using the client context.current property. After we have established the context, we create list creation information object, which is used to store the details concerning the list to be created. We also use the list item creation information object to create new item to just created list. As a final step, and we actually execute the actions by calling the execute query async method available from the client context object. Due to the nature of the Silverlight application, this call is done asynchronously so that the application does not freeze until response from server is got back. There's no additional configurations anymore required for setting up Silverlight applications. When we set up Silverlight development using Visual Studio 2010, we don't have to create supplementary web test project for Silverlight, since we'll be using the SharePoint project templates to deploy the XAP file to development environment. We can also dynamically associate feature framework module element to include the XAP file as part of the files to be deployed. Silverlight application can be deployed using both Sandbox and Farm solution options. Sandbox solution option provides us a rapid development and debugging without need to recycle IIS process as part of the deployment activities. Silverlight debugging is also supported. There's a separate Enable Silverlight debugging option available on the Silverlight tab at the Visual Studio project properties. When this option is enabled, we disable at the same time script debugging and enable the Silverlight debugging. In this demo, we'll show how to set up SharePoint development using how to set up Silverlight development using Visual Studio 2010 SharePoint tool. We'll also cover how to utilize the client object model within the Silverlight application to access SharePoint information within the server.
In this demonstration, we will concentrate to demonstrate how to do Silverlight development in a SharePoint 2010 environment and how we can utilize the client object model to access the information remotely from your Silverlight application to SharePoint farm. It's kind of one of those things which we need to do or understand as part of the Silverlight development is that the Silverlight application itself is actually running on the client side. So it's running on the browser. And that's the reason why we need to have this remote access to be able to access the SharePoint list information, for example. Let's start by creating the initial Silverlight application and structure for the Visual Studio 2010. So we start the Visual Studio and we start a new project. And since we are doing Silverlight applications, we can start by creating the actual Silverlight application project, which in this case could be something like SharePoint 2010 demo. And we start name the project and start creating the actual project type. Since we are using a SharePoint project type to deploy our Silverlight application to the SharePoint, we don't need to create the ASP.NET Web Application project to test our Silverlight application. So let's not create that one. Let's click OK and move forward in our solution creation. So here's our Silverlight application, and let's add a few controls to the actual Silverlight canvas so we're able to demonstrate the functionality a little bit from the UI as well. Let's add a button and let's add a text box or label to the field or the canvas. So we're able to click the button and update some value within the label. Let's switch the controls. That's totally fine. Let's not concentrate on the UI design at this stage. Let's, however, a little bit resize the actual canvas which we're using. And here we go. So we're able to host the Silverlight application in a smaller area. Now that we have the Silverlight application available, let's add also some code for the button to update, for example, the label information, just to show that we are able to debug also the Silverlight applications easily when we do development with the SharePoint 2010. So we have the label 1 and content equals, here we go, and we update the label 1 based on the click which we have in button 1. Let's add a breakpoint here so we're able to hit that breakpoint whenever we start Silverlight application in the SharePoint. Since we want to deploy the Silverlight application to the SharePoint, the easiest way to deploy it there is to use SharePoint project types in Visual Studio 2010. So let's create a empty SharePoint project and let's rename that as a Silverlight demo. And the first thing, as always, we need to define what kind of SharePoint solution we want to use and what is the URL we use for debugging. Let's use the rootnet of our internet, and since we are doing Silverlight development, we are able to do this using the sandbox solution option. So there's no point of doing farm levels deployments of the solutions since Silverlight applications can be deployed as a sandbox solutions. Let's finish the creation and we have the initial structure ready. So how do we actually deploy the XAP file as easy as possible from the SharePoint project? We can add a module element to this project. So let's add a module and let's name that as a SL deployment. And within the module settings, let's first of all delete the unnecessary txt file since we don't want to deploy that. But let's add an let's add an association from the module to this Silverlight application. So we're able to create this reference from the module element so that the Silverlight application is automatically compiled as part of our SharePoint solution. So we define this project output reference, and let's add a single member. And what do we want to actually add? We want to add the SL app demo. Actually, Visual Studio Tools already recognized that this would be the proper. No, actually, that's the SharePoint project. So let's choose the SharePoint 2010 demo, which will be the one which actually has the Silverlight XAP file. And the way we actually want to deploy it. So let's deploy that as a element file, which basically means that we are deploying it as part of this feature to some existing list or some URL. And then therefore we can actually utilize that XAP file directly when it has been deployed. And the key point here is also the fact that now that we have created the project output reference, the XAP file URL and the XAP file path elements have been updated and created for us. So we're basically ready to go for testing. One additional thing which we want to do, since we are developing Silverlight applications, is to set the Silverlight debugging on from the SharePoint tab of the project properties. So we are clicking the Enable Silverlight Debugging instead of Script Debugging option on. And this will ensure that we actually are hooking up the proper processes which are running on this computer to be able to debug the actual Silverlight application. Let's close up all of the files which are open and save the changes. And have one more look on our deployment model. So we're using a module to deploy our XAP file directly to the SL deployment folder, which will be automatically created on the SharePoint site. And there's the XAP file, which we need to also know when we are creating the association from the Silverlight web part. And we're good to go for testing our actual deployment. Since this is a sandbox solution, the deployment will happen relatively fast, so we're able to deploy and build started, build progress, deploy started. So we're able to see that we are having quite a fast progress of getting the information in. And then we can request the page from the UI and configure the Silverlight XAP file to be visible. I haven't enabled the debugging yet, and I'll show how it's actually done. But let's first have the Silverlight present on the site. So let's take the page on edit mode. From insert, from web part, we are able to select the Silverlight web part, which will be used to host our Silverlight application. And in here I can then define the URL of our XAP file. Let's use in this case the intranet.contoso.com and SL deploy and the XAP file, since that was the location where the XAP file is located. And now that the settings have been done, our Silverlight with a single button is hosted on the Silverlight web part, and we are basically ready to go with the debugging. One more thing which I wanted to show from this Silverlight web part is the following. The web part itself supports defining initialization properties for the hosted Silverlight applications. So we're able to, within here, we're able to pass those initialization properties or parameters for the Silverlight application, which we can use to parameterize the application any way we want. Let's click OK to close up that one, and let's save the changes within the site. And there's our really good looking Silverlight application. So now that we want to actually debug this application, it's really simple. So let's open up our SharePoint solution one more time. Since we had enabled the Silverlight debugging for the SharePoint project, from the project properties, we can just press play and start debugging directly from here. And since it's a sandbox solution deployment, the actual debugging doesn't take long. Now I actually did a minor mistake. I started an HTML page, but let's redo the configurations. So we want to set the SharePoint deployment project to be as the starter project. And when that has been done, the SharePoint project will be responsible of uploading the latest version of the XAP file to the location which has been defined within the module element. Let's press play one more time or start the debugging, and let's attach to these processes. Now there's the Silverlight application, and since we added the breakpoint to the Silverlight application, when we click the OK, we have a breakpoint in our Visual Studio as well. And this way we can really easily walk through the code and make sure that also our client object model or whatever we are doing within the Silverlight application is working properly. And as you see, this took a few minutes to do, so really straightforward. Good, that's good to go. So let's close up. So this is the way you create the initial structure to start Silverlight development. So how do we actually use the client object model in our Silverlight application? I have created earlier this smaller application to be available, which I can show and deploy, and we'll walk through the code a little bit. I will delete the existing or remove the existing subfile from the UI and modify the hosting area. So let's leave this to be as empty. It's a required field. Okay, let's wait for the new web part Silverlight to be available. So let's move the Visual Studio aside and let's have a look on the client object model handling. In here we have two different Silverlight applications available. We have a relatively simple Silverlight client OM demo where we actually provide a UI to create announcement lists. So we are using the client object model within the Silverlight application to connect to SharePoint and to create those announcement lists to be available based on the functionality or based on the end user's input. Let's add a breakpoint there to wait for us in the debugging. And then we can walk through the different steps and what actually happens. But basic difference compared to the .NET development within the Silverlight is the fact that Silverlight is a asynchronous development experience. So when we use the client object model in here, the model is relatively the same. So we need to first initialize the client object, client context, and we're able to use the client context.current to get the context, SharePoint context on that particular site. Then we define these actions to be done. So we're telling what kind of elements and what kind of lists and so on we are actually interested of. And then we actually execute the operation by running the execute query async. And there's two delegate functions here called. So if the execution is successful, we are calling the succeed listener, and if it fails, we are calling the fail listener, which are basically the events in here. So there's the operation succeeded and operation failed. And these are basically, we are showing the success or the failure of the list creation based on the end result from the server side. There's the breakpoint is available. Let's have a look on the deployment model. So in here we have few example images included automatically. We also have a image library creation automatically, and those are used for the sample media viewer, which we will have a look after a while. And then the actual deployment of this Silverlight applications is done in a similar way as we did for the initial demo or the first demo. Basically meaning that we have created the project output reference for these two Silverlight projects, and those will be encapsulated to the SharePoint project type, which will be responsible of deploying the subfiles to the SharePoint. And in this case as well, we are able to use the sandbox solution option. So let's press or start debugging, and we basically deploy our Silverlight applications to these two URLs. So let's take that URL address, since we will use that for the Silverlight web part. The solution is being added to the SharePoint, and the features are activated, which basically means that also the images, which we will take a closer look a little bit later, are uploaded to the site. And now we can, since we know that we have those new XAP files available, we can configure the Silverlight web part to show those files. So let's edit the web part properties. Let's configure a new address to be shown, which is the following. So XAP deployment Silverlight client OM and a XAP file. Since that was the target we defined for the module element in the SharePoint application. Let's click OK, so we're able to see this another Silverlight application which we are using, and which is using the client object model. So basically the idea of this application is to show that how do we actually create lists from the Silverlight application using client object model. Let's name the list announcement list to be created as an Ignite, and this is description, so created using Silverlight object model. And since we have enabled the debugging also in that project, when we click the button, we are able to walk through the actual code which we have in the Silverlight application. So we're taking the client context, we are creating a new list creation information object which can be used to create these new lists. We are creating or taking the text input from the end user concerning the description and a title, and we are creating announcement lists, setting the quick launch option, and we're adding that to the lists object of the particular web application. And we also want to add a single item to that announcement list, so we're adding a list item creation information object as well, defining those values which we want to use and update the item. And then we actually call the execution of the actual calls. And let's have a breakpoint in here and here, so we're able to see the end result. So let's start creation, and the operation was succeeded, and we can debug this through as well, and we can move on within the creation process. So from the status we can see that it was success. If we now go to the lists or view the all site content, we are able to see that the announcement list called Ignite was created, and also new list item was created to this particular list. So we manipulated the SharePoint directly from the Silverlight application. This is a relatively simple example for creating information. Let's also have an example on how can we access the list information and use that, for example, to show images within the Silverlight. So let's switch. I will first go and get the URL of the application. So we deployed two different XAP files to be available, and the other one is the sample media viewer, which is relatively simple media viewer application. If we move back to the internet, we can modify the web part to show that particular application. Obviously we could add multiple Silverlight web parts to the page as well, but this is much more easier in demonstration point of view to show the different applications one by one. Let's click OK, and we have a new application available. And how this application actually works is that we are listing different images from one single list within this site, which are uploaded there as part of the deployment of the SharePoint project. And these lists are actually available within here. So we have created a picture list to where we have uploaded 5 different images to be available. And obviously, well, definitely we can access this list information, and then we can show these individual lists based on the user selection on the Silverlight application. So we're making connection from the browser side to the server side and getting the information concerning individual image and showing that within the Silverlight. Quite simple, but let's have a look how it's actually done using the client object model. So for this particular application, let's have a look on the Excel code. We can parameterize the doclib to be used. It has default value if it haven't been defined. We are accessing the information within the list by using the client context, and we are getting the list by its title using the mywebLists get by title, and we are creating a query to get all of the items within the list. And in here we are actually creating the link which specifies what kind of information do we actually want from the list columns. And since we're only interested on the description and title and the URL, we can access those directly using and only those columns if we specify this correctly. And the actual execution is done using the execute query async method. On query succeeded, if we go to that particular function, when the query has been done successfully, we have the actual items loaded, and we can loop through the different items which are available. And for these items, we're able to create this information concerning within the list box. So we're able to show the title of the image, and based on the selection, then on the list box we are uploading the correct image to be shown. So for the list box handling, what about the final steps? Let's go. There's the list box 1 selection changed. So this is the event which will happen when we are actually switching the image to be shown. So if we move to the front page of the site and switch to Waikiki Beach image, we are getting the selected index from the list box. Moving forward, we are loading or opening up actually web client and opening up connection to load the actual image information. And then we are updating that to the canvas of the Silverlight. Let's have one more look on the actual web client implementation. So the web client function implementation is here. So when the actual read of the web client has been done, we are in here, and we're able to update the image source and the large picture source to that particular image. So let's do this one more time from the UI. Let's close this one since we don't use it. And from the browser, so let's select the C. We go to the listbox 1 selection changed. We move forward. When the web client open read has been completed, we are able to get the actual stream resource information, which basically has now the information concerning the particular image, and we're able to create a bitmap image from that stream, and then we can set that bitmap image to be shown on the background of the Silverlight application. Relatively simple, relatively straightforward. And the whole point being on the fact that we needed few lines of code to access the information within the SharePoint site using the client object model. And the only thing which we already actually mentioned, concerning the Silverlight applications, we need to add references to Silverlight specific client object model assemblies. And these are available from the C program files, common files, Microsoft Shared Web Server Extension 14, template layouts, client bin folder. And I'll show the folder immediately. So underneath the layouts we have the client bin folder, which is actually having these two assemblies which we can reference within our Silverlight application. I think we're good to go and continue with the slides.
In this section we'll cover the JavaScript client object model and how we can utilize it, for example, in your ribbon customizations or from your own custom web parts. The JavaScript client object model is easily added to custom ASPX pages. We'll need to reference the sp.js JavaScript file located within the underscore layouts URL. You can do this by adding SharePoint script link control to your page. All JavaScript files are crunched for performance, which means that the size of the JavaScript files has been minimized to decrease the page loading time. There's also debug-enabled versions of the JavaScript files available. You can toggle which file versions are used in SharePoint by modifying the script mode option in the web application configuration file. There are minor differences on the method signatures compared to the .NET and Silverlight client object versions. Also, the data value types are different to the nature of JavaScript. As mentioned in the previous slide, JavaScript client object model files are located in the layouts folder under the 14 root folder. We can access this from the browser side using the underscore layouts URL. There's also a separate debugging versions available, which enables and helps developers to walk through the code more easily. As you can see from the slides, there are quite a few differences on the sizes of these debug and optimized versions. This is an example usage of JavaScript client object model, which also demonstrates the differences in the data value types. Similar way as for other client object models, we'll first need to establish context. Following step is to identify which objects we are interested in using the load method in the client context object. Actual execution of the request operation happens asynchronously by calling the execute query async method available from the client context. In this case, we are assigning function delegates on success and on failure depending on the end result of the call. Notice also for example, how we use different ways to access the object properties in JavaScript client object model. On success function, we are using the get underscore title to get information concerning the particular site's title. This demo will show how you can utilize the JavaScript client object model in your own customizations.
In this demonstration, we'll concentrate on the JavaScript client object model, which gives us the power to access the SharePoint information and modify the SharePoint information directly from the JavaScript. So we basically can execute code in the client side in the browser using JavaScript, and we can still manipulate the SharePoint information within the server side. The JavaScript client object model is based on the same functionality or concept as the Silverlight object model, client object model, and the .NET client object model. So we're basically using the client SPC service to truly manipulate the structures and to communicate between the client object model and the server-side object model. In this example, we have added a example web port on the front page of the intranet, which will demonstrate the functionalities which are available. You could definitely have the same code associated, for example, to ribbon button, which might have been implemented. A lot of the out-of-the-box ribbon functionalities also utilize the JavaScript client object model to manipulate and access the information within the SharePoint. So within this implementation, we have this UI interaction and client OM demo, which demonstrates the functionality. And when we click the link on the page, we start up this pop-up using the dialog framework, which is a custom page or custom pop-up as part of our actual solution. And in here we can define the list to be created. So the demonstration actually creates a announcement list based on the information which we are entering to this pop-up. And the announcement list, the key point here is that the announcement list and all of the operations which we are doing are done on the client side. We are accessing the server side and manipulating the server side structures using client object model, the JavaScript client object model. So when I now click OK, the list creating list ignite is shown, and the list ignite has been created in a few seconds. And within the list ignite, we also created one example item for the ignite list, which will basically show some of the functionality or the capabilities which are available. Let's move back to the front page of the site and have a look how this actually has been implemented. So if we take a closer look on the web port which has been deployed, we can see that the web port itself is deployed as a visual web port functionality. So it's a list creation pop-up visual web port, and then there's the list creation UI action or the actual pop-up ASPX page, which is included in the solution package as well. The actual implementation of the JavaScript is placed mainly on the user on the visual web port, so we're able to see from here how we open up the pop-up. So we're making dialog options, setting the options, and then we're setting up the return values based on the user input on the pop-up. And we're showing the actual dialog. When we get the return values back, we're able to check is the return value OK or is it cancel. And if user has clicked the OK and we get the sufficient information back, which basically in this case is the list name to be created, we can start the creation of the list, which is in its own function. And this is where we actually start using the client object model. So since we are using out-of-the-box ASPX pages, all of the necessary JavaScript files are already there. So we don't have to include those within the user, within the visual web part. We can access this client object model using the SP notation. And in a similar way as for the .NET client object model and for Silverlight client object model, we need to first create the client context. After that, we can start creating different kind of objects. In this case, we are creating the list creation information object, to where we are setting the title and template type and the quick launch option. As you see, this is a little bit different than the signatures of the Silverlight or .NET client object models, but basic concepts are still the same. In this case, we have created the list creation info object, which will be added to the lists collection of the particular web. And we also add a new item by using the list item creation information object, to where we can actually assign the values. In this case, we've assigned values for the title and for the body. And then we are setting these objects and information to the client context. So we're setting those objects to the load method, and the actual execution, the server side, or transmitting this requested operations, the server side is happening in asynchronous mode by executing the execute query async method or function. Since JavaScript functions or JavaScript client object model is asynchronous, we are getting the result back on these query succeeded and query failed functions, which have been associated to the execute query async using function delegate. If everything goes well, and we have been able to execute or create the new list. We are actually gonna sleep a little while just to make sure that we actually are able to see that our messages are showing properly within the UI. Otherwise, the functionality would be way too fast and the notifications which we are showing in UI wouldn't be visible. So that's the only reason for the sleep in here. It's a demonstrational purposes. In real life, we would obviously get rid of this line. And then we are getting the remove. We are calling the remove notification, which will remove the creating notification. Then we are adding that the list has been created. And as a final step in this example, we are moving the default view of that particular list, which was just created. So we get a nice circle and we get directly redirected to the actual URL. And it's totally up to us as a developer to design the process and what kind of functionalities we have within our JavaScript. Let's have a look on the functionality one more time and also how we can debug this JavaScript. So the debugging, if your JavaScript code is placed on a JavaScript file, you can really easily use the Visual Studio 2008 and script debugging. But since this JavaScript is placed on the actual visual web part or the user control of the visual web part, this is a little bit more complex, or where the debugging within the Visual Studio directly is a little bit more complex. But we can still use the developer tools which are available within the Internet Explorer. So if I open up the developer tools, I can switch the script tab from where I can actually start the debugging itself. And in the script tab, I want to first find my own JavaScript and add a breakpoint to the JavaScript so that we are able to walk through this code and how does it actually execute. Let's add a breakpoint also on the onQuery succeeded functionality, so we're able to truly see the different objects and what actually happens. So now if we start debugging on the page, the breakpoints will be available, and let's make sure that they are still there. Just in case, there's my breakpoint for the create list, and there's the breakpoint on query succeeded. Basically meaning that if we move back on the site and start the functionality one more time, and let's name the new list as SharePoint SB 2010, we are hitting the JavaScript breakpoints, and we are able to walk through what actually happens within our JavaScript as well. So if we, for example, are interested on the list creation info object, we are able to add watches and add these objects here as well. The list creation info. So we're able to see what kind of information is available and how have we set it up. And we can move through with the code using the F10 or the steppers or the buttons in here. But step over basically means that we are moving forward within the JavaScript itself. The list name which was entered, we can see that also using the watch. So we requested a list called SB2010 to be created, and moving forward and adding the load operations to the client context and actually executing the call. It will start calling the server side, and when the response is coming back from the server side, we are removing the creating event from the UI. We are adding the new notification concerning that the list has been created, and as a final step we will go to the default view URL of particular list. And if I want to see, for example, what this property is all about, I can definitely do that also using the watch mechanism. So we would be redirected to lists SB2010 all items ASPX page. And moving forward, within the UI we are redirected in here. Quite straightforward, quite similar as the as the client object model in Silverlight and .NET, but the only difference is now that the signatures of the properties and functions are a little bit different, but we can utilize these, but they're really close to the .NET and Silverlight as well. And we can utilize the JavaScript client object model definitely in the ribbon functionalities or within our custom web parts or wherever you need to do some kind of operations. And as you saw from the code, we were forced to use sleep to give us more times, which basically means that the operations are executed in a really, really fast way. So the performance of this model is also really good.
In this final section, we'll concentrate on the new REST interface available to access list information remotely. REST-based interface supports reading, inserting, updating and deleting list information, and it can be easily utilized from Visual Studio 2010 or from any other technologies as well. REST-style architecture consists from client and servers. The clients initiate requests to the servers. Servers process the requests and return appropriate responses. Requests and response are built around transfer of representations of resources. A resource can be essentially any coherent or meaningful concept that may be addressed. A representation of resource is typically a document that captures the current or intended state of a resource. SharePoint uses lists to store information as list items. This is a natural fit for REST-based access, meaning that the list item is a single resource. The REST is a uniform interface, and it can be used to easily integrate information between different systems. WCF Data Services is an add-on to .NET Framework 3.5, which provides RESTful conventions and frameworks for data access. It builds on the top of the AtomBub standard. WCF Data Service model enables us to use consistent tools and client libraries to access RESTful information. So how does the REST actually work? All requests are just HTTP operations. The items within the SharePoint lists are the REST resources, which are presented in XML format. There's uniform URL conventions for access and manipulating list information. There's also multiple different representations of the information available. So how does we actually access the data using the REST interface in SharePoint? The client application is using HTTP operations to manipulate the information inside of the SharePoint. On server side, there's a specific list data SVC service, WCF service, which handles the HTTP commands and returns the requested information in XML format. List data SVC converts the HTTP operations to actual server-side operations and performs the request that calls the server-side object model. Since this is all about just HTTP operations in XML, we can use the REST interface to easily integrate any application built in .NET, Java, Flash, Silverlight, and so on. As mentioned already in a previous slide, REST interface supports multiple different operations which are mapped to HTTP verbs. Depending on the HTTP verb, different operations will be performed on a server-side code. All the SharePoint rules still apply during the updates or inserts of data, like validation and access control. This slide demonstrates the different URL conventions which the REST interface supports. We can use different kind of URL conventions to access information in different levels of the list data. We can request all lists, single list, single item, or even a single column of particular item. For presentation purposes, there's also multiple different conventions available. We can sort and filter the results shown or use projection to view only specific columns of data. There's also other conventions available, like paging the list information. There's integrated support available for data services in Visual Studio 2010. We have libraries for .NET and Silverlight with a full integration in designers and visualizers. There's also a feature-rich client library for .NET, which will generate the necessary code to access the information automatically. Generated code supports Sling and more advanced functionalities like change tracking and patching. You can easily also update the information in the server side using these automatically generated classes. Notice that to enable RESTful interface within your environment, you'll need to install the WCF Data Services 1.5 to each of your servers within your SharePoint farm, or actually on those servers where you want to access to. This demo will demonstrate accessing SharePoint data using a RESTful access. Demo is using Windows Forms application to demonstrate the process, but the key code can be also used in any other technology. Commands are sent to SharePoint using HTTP requests, and the responses are for XML. As mentioned already in the previous slides, this model provides easy interface also for non-Microsoft technologies.
In this demonstration, we'll concentrate on the REST-based access to SharePoint list information, which we can use to access the information remotely using a atom format, which provides us the information concerning the list items and the individual lists using XML-based rendering and XML-based data. In this site, we have two different lists available. So we have the employees list, which has 3 items in it. There's 3 individuals which are actually associated as the primary contacts for these projects. And if we want to access this information using the REST-based access, first of all, we'll need to install the WCF data services to the server, so that the REST-based access is available. After that, as long as we know the URL to contact to, we're able to get information concerning the list data which is stored within the site. So if we access the list data SVC, which is the service responsible of the REST-based access, we get information concerning the individual lists within the site in XML format. And all of this execution and accessing this information obviously obeys and follows the permissions. So I need to have permissions to access this information, otherwise the execution would fail. So there's no way of accessing any information which would be sensitive or restricted. The list data SVC understands different URL commands, and we can use these commands to further filter down what kind of information we are interested. So if we actually want to see the projects, we can extend the URL to have the projects in it. And we would only get information concerning individual projects list. And within the XML, we can see the individual items as well. There's the item number 1, which is the SP 2010 Ignite developer. There's additional items as well. So by expanding the URL, we can filter down different information which is available. If we, for example, want to see the item information related to the project item 4, we can actually copy-paste the URL from here, or we can expand the URL directly within the browser. So let's only see information concerning the 4th item in the projects list. And in this case it's the coffee machine project, and it has information or the description new coffee machine purchase project, and there's always also primary contact associated to this project as well. So using this URL based approach, we can even further down filter these values. And the REST-based access actually understands also those associations, as in lookups or relationships between the lists. In this case, the projects list has a lookup to employees list. And if we want to see the information concerning the primary contact of the particular project, we can further again extend the URL and access the primary contact data by using this proper way of creating the URL, actual URL to be executed. And in this case we can see that Vesa Juvonen has been associated to that particular project to be the primary contact. So this is also the way we can access the information really easily from any external system. As long as we are authenticated and we have HTTP commands available, we get the information of the list data in this XML format. There's also possibilities to actually filter down or change the presentation options for these listings. So in this case I'm listing all of the items in the project's list. If I want to, for example, list these items in a different way, I can say that we are interested of ordering them in a certain way. So order by equals title. And that would basically mean that we are listing or ordering the end results basically based on the title. One thing to be aware when we are implementing anything or implementing customizations over the REST interfaces is the fact that the REST interface is case sensitive. So if I want to access the project's list information, I need to write the list name in the same way that it is actually created. So if we use the different way or different access URL, we can see that we are unable to access the project information since the URL is case sensitive. So changing the projects with a capital P, we are able to get all of the items within that project. So REST is all about accessing these resources, and resources in our case are the list items. And since this is a kind of a standard way of accessing information, we can really easily implement functionalities on top of this. And Microsoft has provided additional tools to make this even easier. So let's actually write a small Windows Form application which will access this data and present the project information within its UI. So let's create a Windows Forms application. It doesn't matter what the project name is. And we can then start using these new capabilities which are available in Visual Studio 2010. So we're able to connect or create a data source which is a SharePoint data source, and we're able to connect to this REST-based interface to get information from the particular list. Just that I'm not writing any typos, let's copy the service name from here and move back to the Visual Studio. And we are accessing the list data SVC, and we can see that the access or the URL is correct if the access is successful in the Visual Studio. Here we go, and then we can actually name the namespace. Let's call it intranet data. Click OK, and we have a connection created. And Visual Studio already associated the required references and so on to our Windows Forms project. So now that we actually have the connection on, we can drag and drop items or lists directly to our Windows Form application, which will generate all of the required classes and access points to modify this data and access to that data. So let's actually get the projects list to be available within our Windows Form application. And we are interested of listing certain fields within the projects list. So let's take the properties and edit columns which we actually want to see. Let's leave only the title, description and due date to be visible and click OK. So we now have almost everything up and running. The only thing we need to do is enable or tell which kind of authentication we're using and what is the actual context when we are requesting this information. So let's go to the form load event, and first of all let's create that actual intranet data context. And we have the context intranet data context available, and let's create new instance of that object. Context equals new data context, and for that we need URL, so let's create new URL. And for this URL we need to use the same URL on the site which we are accessing. So let's again copy the proper URL from the browser. Moving back to the Windows Form side, passing the proper URL to this context identifier, and after that we have created the context properly. The following step is to ensure that we have the data binding done as long as immediately when the form loads. So we are able to first of all set the credentials, which credentials we are using when we are accessing this data. Since all of the data, the REST interfaces are of course following up the permission settings, we need to ensure that we are accessing the data with the proper access rights. So let's access this data using the credential cache, and we are missing one using statement. So let's add using system.net, and from there we can use the default credentials, which basically means the credentials of the particular user who's running the application. And after that we can set the employee or the intranet data employee. What was the name of the object which we created? It's actually projects binding source, so we are actually accessing the project data. So let's actually access that information or update our code. So projects binding source data source equals context, and we're interested of the project information. And basically we are good to go to access the information remotely from our Windows client from anywhere in the world, basically, to that particular URL, as long as the permissions are done properly. And now we can see the information which is available from the list item. Using the similar model, we can even further down implement additional functionalities like delete or item adding and so on. Just an example of a little bit more complicated process or project. This is based on the same model where we have created a service reference to that particular those items within the lists, but we have created this two-dimensional filtering mechanism, so we're able to see those projects where the primary contact is employee 1, 2 or 3. So we're listing those projects on the right side based on our selection. And the amount of code required for this is surprisingly little. So if we actually take a look at the amount of code for the actual handling of the data and associations, that's really small. We can also use the save methods, and we can also save and update information back, or we can also create new items within our Forms application using the REST-based interface. So the REST-based interface is not there only for accessing the information. We can also create new items. So let's add schema force. Here he is an architect from MS Online, architect, and city is Helsinki as well. Clicking to save will actually start the process of updating the information directly to the list itself. So if we go back to the site and employees list, we can see that we have created a new item which is schema force with a misspelling of the architect and city as Helsinki. So within the Visual Studio 2010 we have this ready-to-be-used tools which can utilize this REST-based access to SharePoint information extremely efficiently. And you can definitely utilize the same REST-based access if you have some alternative technologies which need to be accessed to SharePoint information, since it's all about HTTP request and getting the XML response back from the server side.
That sums up our module. We started with the introduction of the client object model and how it has been implemented. Then we covered the 3 different client object models available. As a final section, we concentrated on a RESTful interface, which is now available also for list information in SharePoint. Thanks for your time, and hopefully this presentation was useful.